Welcome to the tutorial over 6.3, square root functions and inequalities. Your new vocabulary is square root function, radical function, square root inequality. Okay, so the first thing we're going to talk about is the parent function of a square root function. We should have learned this back in chapter 1 or 2 when we talked about parent functions. We have f of x is equal to the square root of x. That's the absolute most basic square root function we have. Our domain is anything greater than 0, so 0 to infinity. Our range is anywhere from 0 to infinity as well. We have intercepts at x equals 0 and y equals 0. It is not defined for anything that's negative because technically we can't have negative square roots. Anytime we get those, we get complex numbers with the I. And the end behavior is as x approaches 0, our y value approaches 0, and then as x approaches infinity, our y also approaches positive infinity. Alright, so example number 1, we're going to identify the domain and range of f of x equals the square root of x minus 2. Alright, so the first thing you want to do is set whatever's underneath your square root sign equal to 0. And the reason why we're doing that is it's going to show you basically your threshold of anything below this x value is going to give you an imaginary number or a negative under the square root. So that's why we want to see where it equals 0. We're going to add 2 to both sides. We're going to get x equals positive 2. And what that means is that our function actually looks like this on our graph. And if we went anywhere to the left of 2, it would give me a negative under my square root, and that's not what we want. So the domain, curly brackets, oops, that's an ugly looking curly bracket, x such that x is greater than or equal to 2. Now it can actually be, God, that's a horrible looking bracket. Sorry. Anyways, this is saying everything that is greater than 2, it can actually be equal to 2 because you can get the square root of 0, which is 0. So that's okay. Alright, so we need to find our range. And if you actually look at this on a calculator and you graph it, you get the same picture I did to the right. And it's going to actually have the same range as our original parent function. So you go from y such that y is greater than or equal to 0. Curly brackets look much better. Now if we want to get super fancy, we're going to say f of x instead of y such that f of x is greater than or equal to 0. It means the exact same thing as what I just wrote, but sometimes you might see it either way. Alright, so let's talk about transformations of square root functions. Alright, so we have h, which is our horizontal translation. Think of what's underneath the square root as backwards rolled again. If it's minus h, it means it's going to move to the right. If it's plus h, it's going to move to the left. The k is going to be your vertical translation, so it either goes up or down. And then the a is going to be your orientation or your shape. So if a is less than 0, meaning it's negative, it's going to reflect across the x-axis. If we have the absolute value of a is greater than 1, it's going to be a vertical stretch. And if it's in between 0 and 1, it's going to be compressed. So example 2a, graph the function y equals 3 square roots of x minus 4 plus 2. State the domain and range. Now what I want you to do is first identify the transformations that happen on your square root function, but I'm going to have you actually graph this in your calculator. Alright, so the first thing I want to look at is this 3, and we have to think to ourselves, what exactly does it do to our function? And since it's positive and it's a greater than 1, it's going to be a vertical stretch by a factor of 3. Now we want to look under the square root. Alright, so that's a minus 4, and we have to think of that as backwards scrolled. So since it's a minus 4, you would think it goes to the left, however, it does not. It actually goes to the right 4. And the last thing we're going to look at is this plus 2. It is actually on the outside. Since it is positive, we're going to go up 2 units. So if we were to actually graph my original square root function, it would look something like this. Now my new function, once I actually plug it straight into the calculator, exactly the way you see it, in your calculator you'll have f of x equals, and you don't have to type that part, but you can type 3 square root of x minus 4 plus 2. Now sometimes the calculators can get persnickety, so you might have to put a time sign in between the 3 and the square root. Also, if you don't have a calculator at home, you can download the app called Desmos, and it's a free graphing calculator, and you should be able to look at it that way. So anyways, on the same graph, you should get something that looks kind of like this. So all we did was take my function and transformed it. Now we actually have to state the domain and range. Alright, so now we need the domain and range. Remember that we need this to be positive, that's underneath the square root. So we're going to set that equal to 0. Have 4 to both sides. It says x is equal to 4. That's going to give us 0, so we need everything greater than 4. So domain is in x such that x is greater than or equal to 4. And the last thing we're going to do is our range. And notice how when we shifted up 2 units, we're starting at 2 rather than 0, and it goes to positive infinity. So our range is in f of x such that f of x is greater than or equal to 2. Alright, example 2b, graph the function y equals negative square root of x plus 5 minus 6. State the domain and range. Alright, we're going to talk about the transformations again. This negative sign means that we're going to flip over the x-axis. This x plus 5, remember, is backwards scrolled. You would think it would move to the right 5, however, it does not. It moves to the left 5. And the last thing, we have this minus 6, means we're going to go down 6 units. Now you can graph that in your calculator. Remember, we have our original square root function that looks like so. And our new function looks like something like that. Okay. Alright, so from that, we should be able to get our domain and range. Again, we're going to set whatever's underneath the square root equal to 0. So x plus 5 equals 0. Subtract 5 from both sides. X equals negative 5. So that means my domain is x such that x is greater than or equal to negative 5. And now we have to talk about our range. We flipped it over the x-axis, so instead of going to positive infinity, it is now going to negative infinity. And we also shifted it down 6 units, so this is at negative 6. So our starting point for f of x is actually f of x is everything smaller than or equal to negative 6. Voila. Alright, example number 3. When an object is spinning in a circular path of a radius of 2 meters with a velocity v in meters per second, the centripetal acceleration a in meters per second squared is directed towards the center of the circle. The velocity v and acceleration a of the object are related by v equals the square root of 2a function. We're going to graph the function in the domain that a such that is in the set of a is greater than or equal to 0. Now what you can do is you can actually just plug this right into your calculator, and what you should get a picture just like here on the right. Now let's talk about the transformation real quick. We have a number being multiplied to my variable on the inside. Now, when we have something multiplied on the inside, that's actually going to be a horizontal stretch or compression. And you would think it would be a horizontal stretch because that's by a factor of 2, but it's not. It does the exact opposite of what you think it is. So it's going to be a horizontal compression by a factor of 2. Alright, part B of this problem. What would be the centripetal acceleration of an object spinning along the circular path with a velocity of 4 meters per second? Alright, so we have our original function, which is v is equal to the square root of 2a. And what we're searching for is what a is. So we're going to let 4 go in for v. So 4 is equal to the square root of 2a. And now we actually need to solve for a. Now, to get rid of the square root, we're going to square both sides. Four squared is 16. This makes the square root go away. 16 is equal to 2a. Now we're going to divide by 2 on both sides. And we get a is equal to 8. So our full answer is going to be the centripetal acceleration would be 8 meters per second squared. Alright, for our last example, we're going to graph y is greater than the square root of 3x plus 5. Alright, so you can actually graph this in your calculator, but I'm going to talk about a couple things. Now, let's look at the transformations first. If you were to figure out what your horizontal compression was, you would actually have to factor out a 3 first, and then you would be able to tell me how far left or right it went, but we're just going to go ahead and graph this in our calculator. So the first thing is, when you actually graph this, we're graphing the boundary, and since it does not have a line underneath, we have to make sure that we have a dashed function, and also it's going to be an open circle here on the x-axis, so right there. Now the last part is where we're going to shade, and if you take a look at this, this is saying your y values are getting bigger than your function, so we want our y values to get taller than, so that means we're going to shade on top of the function, like so. Now one thing you really want to watch out for, and I accidentally got shading happy, whatever your function is, whatever the domain is, you need to make sure you set the stuff on the inside equal to 0 and solve for it. Because if we subtract 5 from both sides, we get 3x is equal to negative 5, divided by 3, divided by 3. X has to be greater than, actually not equal to, so x has to be strictly greater than negative 5/3. That means we cannot go anywhere past this line. So when you're shading, make sure that you don't go past your function. Okay? And that concludes our video. Thanks for watching.